Hey guys, Mr. Mars again. So today we're going to be talking about pyramids, we're talking about cones, we're talking about surface area of pyramids and cones. Now, just a little flashback reminder, we just got done talking about the surface area of these two guys, rectangular prisms and cylinders, right? We talked about how it was 2b plus pH, and that's because we had two bases, right? And then we had that perimeter times the height. And that was our formula. We used it to find anything from missing sides or finding whatever. With our prisms, we could have rectangular prisms, we could have pentagonal prisms, hexagonal prisms, we could have all those things, right? So anyway, so those were the ones that we were talking about. We also talked about how to find the areas of those objects previously on how to find the area of regular pentagons, regular hexagons, etc., things like that, using that whole apothema and stuff like that. So anyways, so today we're going to switch to another three-dimensional object. We're going to talk about pyramids and we're going to talk about cones, okay? So the difference between pyramids, cones, and prisms and cylinders is pyramids and cones only have one base, all right? Also, the other big difference is that if I look over here, I take these two, I'll use these two for example first. If I look at these, my two bases, they're connected by rectangles. Right? They're connected by rectangles. My pyramid, on the other hand, has one base, and it's got an apex up here. And it's connected by triangles. I know, you thought triangles went away, triangles didn't go anywhere. This is connected by triangles on the side. Matter of fact, with the pyramid, you'll see there are 4 triangles that go up to the apex. If I had a triangular prism, I would have a triangle on the bottom, or on the base, not the bottom necessarily, but the base. And I would have 3 triangles going up to the pyramid. If I had a hexagonal pyramid, which is a hexagon as my base, then I would have 6 triangles going up to the point up at the top. The nice thing is that if it's a regular meaning all sides equal, a regular polygon, like a regular triangular pyramid, or a regular hexagonal pyramid, or a regular octagonal pyramid, that all of those triangles are going to be the same. It doesn't have to be that way, especially with triangular pyramids and rectangular pyramids, but sometimes all of those triangles are the same, so that kind of helps you out. But it doesn't matter regardless, because we're going to actually be doing the same thing. We're going to be going base, just like we did with this guy, but we had 2 of them, that's why it was 2b. We're going to go perimeter, the distance around, just like we did here. And when we did that one, we just multiplied times the height with this guy. But when I do that over here, I gotta change little things because I'm actually doing it with triangles, not with rectangles. So it brings in about a little bit of a different to our formula. The formula doesn't change a whole lot though. Not from the one I gave you. Now the one you'll remember I gave you yesterday was this one for our prisms. It was this. The surface area, and this is for a prism, right? Not a pyramid, was 2b plus ph, right? 2b plus pH. Now, if you'll look, in this one, this makes sense, right? Oops, sorry, good for that to be red. This makes sense. In a prism, we had 2 bases. In a pyramid, we have 1 base, right? And I want to make sure I give you the right way that they put it on your reference sheet, so make sure that they're going to give it to you right here. Pyramids, yep, they change it around, right? So they change it to this, just so you know. Theirs goes b plus 1/2 slanted L P. Okay, we'll talk about that slanted L in just a minute. Okay, so they flip it around. So we have 1 base instead of 2 bases. So we're going to find the area of this. So is it still all about the base? Yes, it's all about the base. Megan Trainer has not left us. It's still all about the base. So I got my 1 base. I've got the P, which is the perimeter of the base. And then I have this fancy L, and I'll talk about that one in just a second, okay? So as I'm looking at my triangles here, you'll see that our objects up here, these are the labels that they're talking about. The capital B is the area of the base. Now, that is not the base because it's on the bottom. It's because it's opposite the vertex up here, the apex, right? That's my apex up there. So it's opposite that. Our base is always going to be opposite that. This on a pyramid can change. It could be a rectangle, it could be a square, it could be a pentagon, a hexagon, an octagon, a triangle, it could be whatever. So we have to pay attention to what that shape is, right? The P is the perimeter. That has not changed, right? So if I put a little letter P right here, P is going to be adding all 4 of those sides together. That's going to be my perimeter, right? Now, the only other thing I have in this list is a slanted L, an italicized L. The italicized L is called the slant height. they don't use an H because they don't want you confused with the regular height. So they used an italicized L. It kind of goes like this, all right, an italicized L. That slant height is saying we don't want the height of the pyramid. The height of the pyramid would go from here straight down to the bottom right here. This would be the height of the pyramid. If I took my pen and put it inside of there, that would be the height of the pyramid. We don't want that. We need the slant height. The slant height is saying if I'm out here on the edge and I'm looking at this triangle, how do I get that? The height of the triangle, the slanted height of the pyramid. This is the actual height of the pyramid. This is the slanted height of the pyramid. And that's what we need. That's what goes in here. That's what that italicized L is, and you'll see it sitting right there. That is my slant height. The actual height is in there. We don't use the actual height on a regular on a pyramid like this in the equation. We might use it to find information, but we don't use it in the equation, okay? So as I look right here, this is my pyramid. I say, okay, my pyramid, the surface area of my pyramid, the formula is capital B plus 1/2 P and slant height, right? I changed the P and the L around also. They can go either way. So I need the area of my base, I need the perimeter of my base, and I need the slant height that's going up the side of the pyramid, okay? So I fill in my information. Well, the first one, again, slant height sometimes is pretty easy to see. It's right up here going up the side. That's the 11.7. That's the 11.7, okay? By the way, that height has nothing to do with the actual base, right? It just is the base up to the side, up to the top at the slanted height. Now, my area, in this case, my base, it looks like right here, is a square because it's 8 by 8. So I'm going to go 8 times 8. My base is 64. That's here in my base. My perimeter is the distance all the way around, right? Remember, all the way around. So it goes here, 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 and here. And so if I do that, that's going to look like this. It's going to go 8 plus 8 plus 8 plus 8, which is 32. Okay, that is my perimeter. And now, the 1/2. So where did the 1/2 come in? See the 1/2 right there? So the 1/2 comes in this way. Do you remember that my sides on this guy were rectangles? Do we take half when we find the area of a rectangle? No, it's length times width, or base times height. But when I do the area of a triangle, I gotta go 1/2 base times height. So I did perimeter is all of these guys times the slant heights, and then I have to take half because they're triangles. So that's where it comes. That's where the 1/2 comes in. So now when I complete this now, I'm going to do the following. I'm going to take my base, which is 64. I'm going to add it plus 1/2 times. My perimeter is 32, and my slant height is 11.7. Now, you technically could type that straight into your calculator and it will give you the answer, but I am not going to do that. I'm going to do it the long way. So I'm going to go, this is 64. I'm going to take my calculator and I'm going to go 1/2 times 32 times 11.7. So let me type these in, 0.7, and then I'm going to go 2, and I get 187.2, and I'm going to add that to the 64. So we add that back to the 64. And I'll end up getting 251.2, and that's going to be meters squared because we're still talking about area, so it's still going to be meters squared. And so that is my surface area. That is the surface area of that pyramid. Now, as we talked about earlier, and I'm going to tell you this now because it may pop up later on, remember the spot that goes around the outside? Remember we had this guy, this was our lateral area, right? Was our perimeter times our height. Well, our lateral area in this one is this guy right here. This is my lateral area. It's the part that's not the base. Okay, you say, well, Mr. Marks, when would you use that? Let me give you a perfect example. Ready? This is my house. This is my roof on my house. I want to know how many shingles I'm going to need to roof my house. I need this part. I don't need the base. I'm not putting shingles on the bottom of my roof. So I would only want the lateral area. I wouldn't need the base, so I would take that part out. I would just do the 1/2 PL, okay? So that's where lateral area comes in. Might have mentioned this yesterday, like if you were going to paint, like if I was gonna paint my house, yesterday, if we were talking about our lateral, if I was gonna paint my house is sitting on the ground. The roof is on top of the house. I only want the lateral area of the house. Okay, so that's where lateral area can come in and can be useful and for different things. We just take the base part out of the equation because we don't need the base. We just want the lateral area. All right, moving down, we'll try another one. I'm going to jump down to this one down here because this brings about a new feature and a new problem. So on this one, I've got, again, surface area. So I'm going to go my surface area is equal to the area of the base plus 1/2 perimeter times slant height. So as I've been doing this whole time, I need the base, I need the perimeter, and I need the slant height, right? Well, the base, again, is still, in this case, it's another square, which is nice of them to do. So I'm gonna go 16 times 16, and that's gonna give me, I think it's 256. I'm cheating, you guys. Yeah, 256. I looked on the back wall. So that's 16 times 16 is 256. My perimeter, right, is gonna be 16 plus 16 plus 16 plus 16. So that's 16 times 4. That's going to give me 64. My slant height, which is usually the easiest part to find, is a problem because I don't have a slant height. I have a height right there, which is 3, but I don't have a slant height. So how do I find that? Well, sorry, but it's back. It never left us. If I connect from where the height comes straight down and I connect over here to this side right here, and then I do my slant height going over like this, up that triangle right there, I have just made myself a beautiful, and I know you're so happy to see them again, a beautiful right triangle. So Mr. Martins, how am I supposed to find the slant height? Well, you know this part's 3, and if this comes straight down, it comes straight down in the middle. So if the whole length was 16, this part is 8. I can now find my hypotenuse. So to get my slant height, I'm going to have to come over here and go 3 squared plus 8 squared equals my slant height squared. This is 9, this is 64, that's x squared, that's 72, that's x squared. I square root 72. So I grab my calculator and I'm going to take 72 and I'm going to square root the 72 and I get 8.485. Now, for our purposes, we're just going to round to the nearest tenth. So 8.485, 8.485, I'm going to round to 8.5. So my slant height is going to be 8.5. So that right there is 8.5. Now I have all the pieces I need for my formula. I come back and I go, this surface area is equal to the base. We already found out the base was 256 plus 1/2 times the perimeter we found out was 64. And my slant height was 8.5. Okay? I multiplied the 1/2. I got to multiply everything on this side over here. I already got the 256, so it's just going to come down. So I'm going to take the 64 times 8.5, 64 times 8.5, and that equals, and I'm going to divide that by 2, or take 1/2, and that gives me 272. And then I add these together, that's going to give me 528, and that is feet squared. Because again, we're still doing area. Okay? So notice nothing's really changing, right? Not a whole lot. These were all rectangular prisms. So now I'm going to try one with a triangular prism, okay? And then I'll do 5 and 6 here. So I'll do a triangular prism, and then I'll do what this one looks like. It's a hexagonal prism, or a pyramid, I'm sorry. I said prism, pyramid. So for this one, again, it's a pyramid. So we're gonna go B plus 1/2 PL, right? That's my surface area. I need the B, I need the P, I need the slant height, okay? The slant height I've identified right away. It's right here coming down the side of that triangle right there. It is 12.2, which is kind of nice. I don't have to try and find that one. My base is this triangle right down here. That is my base. You will notice that that is an equilateral triangle, 7 by 7 by 7. So my perimeter is 7 plus 7 plus 7. My perimeter is 21, right? And then I need to find the area of the triangle. Now, do not forget that the area of a triangle is 1/2 base times height, right? We can't forget that it's 1/2 base times height is the area of a triangle. I need the two measurements in my triangle, my base triangle, which is this guy right here. That's my base triangle. I need the two measurements that meet at 90 degrees. That would be this 7 right here and this 6.1 that's pointing to that line right there. Those are the two that show meeting at 90 degrees. So I'm going to put in here 6.1 and 7. So I grab my calculator and I go 7 times 6.1 times 1/2. And I get 21.35. 21.35. So I have my base, I have my perimeter, and I have my slant height. So I plug them in again, you guys. That's all we're doing. We're just doing formulas. My base is 21.35 plus 1/2. My perimeter, we said, was 21, and my slant height was 12.2. Again, this number is already by itself. We don't need to do anything with that. And we're going to take all of this and we're going to multiply it out. Now, again, just a reminder, by the way, once you set this up, you could type this in your calculator, your scientific calculator, or on your the EOC calculator. It'll do the math for you. But I'm going to go ahead and go 21 times 12.2 times 0.5. I don't want to keep switching the screens back and forth. So I got 128.1. I add those together. I get plus 21.35 equals 149.45. Now, what I will show you, I'll show you real quick. It was 21.35 and it was 21 and 12.2. So I'm gonna go ahead and pull this up to show you real quick that if I clear this off and I go 21.35 and I hit plus, right? Where's my plus? Plus, and then I put in 1/2, so 1 divided by 2, and I click next to that, and I go times, and what were my other two numbers? Sorry guys. My other two numbers were 21 and 12.2, and I go times 21, and I go times 12.2, it gives me 149.45. The calculator does everything for you. You just have to type it in the exact order that you have it on the formula, okay? And mine was 149.45 as well. So you can let the calculator do the work. You just have to get this set up and find the area and formula, the area of the base, the perimeter of the base, and the slant height, okay? Now, so what happens down here? A lot of students get freaked out about this. Don't get freaked out. This is actually easier than most of them because they're doing the hexagonal pyramid. Again, it's a pyramid, so it goes like this. B plus 1/2 PL. They give you the base right there. So just write 93.53. I need the perimeter, I need the slant height. The slant height they gave you, it's 11.3. And all of these markings, I don't know if you can see them up here on the screen, but if you saw them on your paper, all of these markings are going like this. That means all of those sides are exactly the same, and it tells you right here that each side is 6. So there's 6 of them, and they each are 6. So my perimeter is 6 times 6, which is 36. So I come back over here and I go 1/2 of 36 times 11.3, okay? And I type that in my calculator and I get my answer, okay? I'm not gonna type it in, you guys can do that part, okay? So those are our pyramids, right? So we start one base, perimeter, slant height. If they don't give us the slant height, like on this one up here, then we may be required to find the slant height using the Pythagorean theorem, all right? Now, moving on. The next thing we're talking about is talking about cones. Cones follow the exact same formula as a pyramid. Cones and pyramids are exactly the same. Only difference, again, just like cylinders and prisms were, the cone's base is always going to be a circle. The pyramid's base was not. The cone's perimeter is always going to be the circumference, right? Pyramid was not. So for my cone, I'm going to follow the same thing that I did with my pyramid, right? So my pyramid, and again, it's all about the base. My pyramid went like this, right? It's 1/2 PL. My cone does exactly the same thing, but the base is always going to be pi r squared, right? That's always going to be pi r squared because the base is always going to be a circle. Plus 1/2. Well, the perimeter is always going to be the circumference, which is 2 pi r. And then I have the slant height. So we're going to clean that up a little bit. Here's how we're going to clean it up. Do you notice that I'm taking 1/2, multiplying it times 2? These guys cancel each other out. So here's what I wind up with for my final equation or formula for the surface area of a cone. It is pi r squared, that's the base, pi r L. Because I don't need the 2 pi r because it's going to take half, and so the 2 gets canceled out by the 1. That is your formula. Again, if you want lateral area, you don't want the base. So if I'm talking about lateral area, I'm only talking about this part right here. You'll see that right here down at the bottom, okay? Again, where would I use lateral area? Well, this is off the top of my head, a teepee, right? We talked about SOHCAHTOA a while back. Teepee sitting on the ground. I just need skins to cover this part. I don't need it on the floor, right? So that would be an example of a lateral area. You guys could come up with better ones. Grain silos or something like that. I don't know. You guys come up with your own thing. So I need a radius and I need a lateral slant height. I need a slant height. So I need radius and I need a slant height. So if I come up to this one, number 7 over here, my surface area, oops, I don't like that green unless I'm just highlighting. So my surface area is pi r squared plus pi r slant height. I need a radius, I need a slant height. My radius, they tell me is 7, so I put 7. My slant height, they tell me is 11.4, so I put 11.4. And I come over here and go pi times 7 squared plus, I go 7 times 11.4. Oh, sorry, pi times 7 times 11.4. Now remember how I told you I wanted you to keep your answers in pi, right? So our scientific calculator will do this for us. I'm going to show you because I'm going to do the actual math part over here. So this would be 49 pi. Over here I'm going to go 7 times 11.4. So 7 times 11.4 is going to give me 79.8. So this is 79.8 pi. And I would add those two together, right? So I'm going to add those two together. And I'm going to get 128.8 pi. Right? Now, if it said round to the nearest whatever, then we multiply by pi at the end. But I want to show you that on the calculator, it's going to do this. So on the calculator, here's all I need to do. If I'm going to leave my answer in pi, ignore pi. Just do it at the end. So I'm going to put 7 squared plus 7 times 11.4. I'm going to put that in the calculator. So ready? I'm going to go 7 squared, and then I'm going to go plus, and it was 7 times 11.4. If you look, it gives you 128.8. If I go back here, remember I just left off pi, I slap on the pi now, 128.8 pi. And again, if it said round to the nearest tenth, round to the nearest tenth, then you multiply by the pi, put the pi button in there, okay? Or you can even type this, if they want you to round it, type this whole thing right here into your calculator. You can even type this whole thing into the calculator. It will give it to you. You just have to find the parts and put it into the equation, okay? Let's jump down to this guy, all right? So for this guy, number 9, remember, nothing's changed. I still need pi r squared plus pi r slant height. I need a radius and I need a slant height, okay? Well, slant height's easy. Slant height, 27.3. 27.3. Radius, I do not have a radius. However, I do have a right triangle because that's what a cone is. It's just a series of right triangles going around in a circle. So I go, okay, I'm looking for this leg. So I'm going to go, to get my radius over here, I'm going to go leg squared plus leg squared, 25.2 squared, equals 27.3 squared. Now, I gotta tell you, there's gonna be some funky numbers going on right here. So I'm gonna go 25.2 squared, 25.2 times 25.2 equals 635.04. So I have x squared plus 635.04 equals now 27.3. 27.3 times 27.3 gives me 745.29. Now I gotta subtract the 635.04. And that gives me 110.25. So I have x squared equals 110.25. And I gotta square root those, right? So we square root, and I'm gonna square root that, and I get 10.5. So my radius is 10.5. Whew. Now, once I do that part, that's all the hard part though. Because now I'm just gonna go pi times 10.5 squared plus pi times 10.5 times 27.3, because that was my side height. And I can type that straight into my calculator. All right, so I'm gonna take my calculator. Now I'm gonna show you, I'm gonna do it with pi this time, and then I'll take the pi's out. So that was 10.5 squared times pi, right? And then it went plus, and it was 10.5 times pi times the slant height, which was 27.3. And I'm multiplying all of that together, okay? And that gives me a great big answer of 1,246.898. So 1246.898. So this would be 1246.898. So that's going to go to 1246.9, and that would be inches squared. Now, what if I did it without pi? Now, this is where you got to be careful. So I'm going to go back to my calculator. So I'm going to take out the pi's, which is fine here, right? That one I can just take out the pi. I'm just going to back it up. But when I take out the pi here, that pi in there tells me that all this is being multiplied. So when I take out the pi and I go back, I now have to put a multiplication sign in between those things. Okay, that gives me 396.9. So I come back over here, and that would be 396.9 pi. Okay, so you can do it with pi, you can do it without pi. Either one is going to work. It's up to you though. Okay, so you can multiply the one side to multiply the other. Okay, now applications. So let's look at number 11. We want to find the surface area of this object. So here's what's taking place, right? We got ourselves, actually, I'm not going to do that. We'll do those applications later on. I'm going to skip that one. Let's jump down to number 12. Number 12 says the roof of a shed in a square base pyramid, if the base has a side length of 10 feet and the slant height of a roof is 9.4 feet, find the area of the roof. So I'm going to show you how to draw a pyramid. It's really simple. It says it's a square base, so just draw a square like this, okay? Put a point up here above it, and now just draw lines out to each of the corners. And if you do that, you have yourself a pyramid. Yay! It says base pyramid. If the base has a side length of 10, that means, remember, it's a square, so if that's 10, this is also 10. And it has a slant height, so I'm going to put in my slant height. My slant height's going to come up the side right here. A slant height of the roof is 9.4. They want you to find the area of the roof. Okay? Now, pyramid. Remember, our pyramid formula does this. B plus 1/2 PL. However, I don't care about the base. I'm only doing the slant height. That's the only thing that I'm going to put on the area of the roof, because the bottom of it sits on the house. So I'm going to go 1/2 times the perimeter times the slant height. Well, the perimeter is 10 plus 10 plus 10 plus 10, so that perimeter is 40. And the slant height they gave us is 9.4. So I'm going to grab my calculator and I'm going to take 1/2 times 40 times 9.4. So I go 1/2 times 40 times 9.4, and that gives me a grand total of 188 square feet. That is the area of my roof that's been put on my thing, okay? Now, on your homework, I believe this is the homework page. Let me double check real quick before I say anything else. I apologize for stepping off screen for a minute. Yep, your homework is going to be on page 13. So check the problems on page 13. You've got cones and you've got pyramids, okay? So take all the notes, do your homework. I'll see you guys next time.